Hi, welcome back. So I hope you have seen the previous video. This is a continuation of that. So here we'll be splitting the data further on Sunny. Okay. So here what we have 1, 2, 8, 9 and 11. These are the days, right? So I'll just write it here. So D Sunny. Now my new data set is D Sunny. Okay, and it contains 1, 2, 8, 9 and 11. Okay, so this is my new data, and what is the entropy of D Sunny? I think you have got it earlier. What is the entropy of D Sunny? So it is 0.97, right? It is 0.97. So I'll just mark it. Just like in the previous slides, we had marked the entropy of the entire data set, right? It was 0.94. Now this D Sunny is my new data set, okay? Because we have divided, we have come to the one branch of the decision tree. Now here we have the Sunny data set only. We do not have the other data set. So here this is the entire data set, and the entropy of it is 0.97. Okay, so this is my old entropy, which we'll be using to find out the information gain. Now let's break it. So DS means D Sunny. So let's break it into how many parts? Let's say I'll divide it on temperature, because we cannot divide it further on Outlook, right? It makes no sense. So here we'll be dividing the data set Sunny into temperature, humidity and windy, right? We have these three options. We do not have the option of Outlook because we have already divided it. So for temperature and play tennis, okay, so these are the two features which we'll be using. These are the two columns which we'll be using. So let me write it like this. So let's break it as temperature is, I think, how many? So we have, okay, it's 3: hot, mild and cool, right? So let's write hot. How many hots are present? 2 hots are present. Now maybe you are confused how 2 hots are present. Look at this. So we are considering the Sunny data only, okay? Remember that, that's why. So how many Sunny data are present? 1, 2, 3, 4, 5, right? Out of these, how many hots are present? 1 hot, 2 hot. Yes, that's it, right? So that is why I'm writing here 2 hots only, okay? And what are the corresponding play tennis value? It is no for both the cases. Okay, you can check it. Next we have mild. So how many milds are present? In the same way we have 2 milds. And what are the class corresponding to it? No and yes. Okay, so this is D2, and let's say D3 is cool. So how many cools are present? I think 1 cool is present, and that is corresponding to yes. Okay. Now we need to find the entropy. So what will be the entropy on this? See, both are no's, right? Both are no's means we are very sure what the class is. So we can directly write it as 0. Okay, entropy is 0 here. You can calculate it. Okay, you will get a 0, right? And for h of y on D2, what is that? So we have a yes, we have a no. So it is 1, if I'm not wrong. Okay, see, this we have done in the previous slides. Don't worry about that. How am I doing it? You can do it. Just use the formula, you will get it. For D3 also we have only 1 point, and so the entropy is obviously 0. Okay, I'll just show you how you get it. So for H1, so we have 2 points, right? And out of them 2 are negatives. So minus 2 by 2 log of 2 by 2. So what is log 1? It is 0, if I'm not wrong. Okay, so you will get it as 0. and for these you will get like 1 by 2 minus 1 by 2 into log of 1 by 2 minus 1 by 2 log of 1 by 2. Do it and you will get a 1. Okay, and this is again a 0. So you can get these values. Now what is the weighted sum or weighted entropy? So I'll just write HW of D sunny as, so 0 makes no sense, so out of 2 by 14 into 0, I'll just simply write it for it is 2 by 14 into 0 plus sorry, not 2 by 14, I'm very sorry, not 2 by 14, it is 2 by how many what is the total data? It is 5, right? 5 data points are present in DS, that is D sunny, so we'll be using 5 here. 2 by 5 into 0 plus D2 we have 1, right? And how many points are there? 2 points are present in D2, right? So 2 points out of 5 into 1 plus 1 point out of 5 into 0. Okay, D1, D2, D3. So what we get here is so we get here 0.4. So what is the information gain? I'll write it. Okay, maybe in some video, in some parts, you will see my picture here and the data is not visible. So you just focus what I'm saying, okay? You will be able to write it. I'm not writing anything which I'm not dictating. So please focus and write it down if it comes in that particular part, because maybe subconsciously I'm forgetting sometimes, right? So IG of D sunny on temperature, right? This is done on temperature, so I'll just write temperature equals to, what is the previous entropy? What is the old entropy? It is 0.97. So without dividing the sunny data set, remember, without dividing the sunny data set, what is my entropy? It is 0.97. And after dividing the sunny data set, what is the entropy? This is 0.4. So what is the value? It will be 0.57. Mark it. Okay. In the same way, I'll not be doing all of them, but in the same way, I'll just write it here. So in the same way, for information gain of D sunny on humidity, you will get the value as 0.97. Okay. Moreover, sunny data set temperature, what do we get? What do we get already? It is 0.57, right? So it is 0.57, which I have already shown you. And information gain of D sunny, when I am doing it on windy, you will get the value as 0.03. Okay. Now which is the highest value here? On dividing on which feature am I getting the highest information? It is on dividing, if I divide it on humidity, if I divide the D sunny on humidity, I will get the maximum information. Okay, that's why in this picture, yeah, so in this picture we can now increase this, we can build the tree, like, so here we'll be increasing it on humidity. Okay, right? So on humidity, now how will it look like? So humidity has two parts, right? So one is high, another is normal, right? So on high, how many points are present? Just a second, I'll move it. Okay, so on high, how many points are present? We have 1, 2 and 8. See, totally in D sunny we had 1, 2, 8, 9, 11. These are the days on which we had sunny data, right? But now we are breaking it on humidity, so we are actually getting two different parts. So one is high humidity, one is normal humidity. So how many of these days we had the humidity as high? On 3 days, 1, 2 and 8, and normal we had on 9 and 11. Okay, so how many positive and negative points are present here? So 0 positive, 3 negative here, 0 positive, 3 negative points, and here we have 2 positive, 0 negatives. See, do the summation. See, 3 negative points here, 2 positive points. See, total was 2 positive, 3 negative. Totally we had 5 points, 5 sunny points. Now we are dividing on humidity, so we have totally 5 points, but now we have divided it. Okay, so whenever we get to this particular part, what we'll say? We'll say this is a no. And whenever we come here, we'll say it is a yes. Okay, see, I'm not sure if you are seeing this. Just see the original one. Just see this, humidity high, normal. Okay, so whenever I say the outlook is sunny, then we'll check what the humidity is. If the humidity is high, we'll right away say no. Now you understand, right, how I have built the decision tree. Now we have already completed this part, this entire part of the decision tree. We have built this. Only the rainy part is left. Okay, so I think you can do it. Still, I'll just show you the values. Okay, in that way it will be better for you to confirm, and it will be a better practice for you, right? So I'll just show you. Okay, so having done this, now we'll get back to this now, D rainy, right? Now we'll be considering the D rainy part. So D rainy, let's not write it here. So now we have D rainy, and I could have made another video for D rainy, but I don't think we need to do that, because you have already got the idea how to do it, right? And it is very similar to what you have done. So I'll just confirm you the values. So D rainy we had 4, 5, 6, 10 and 14, right? The data 4, 5, 6, 10 and 14. These are the days on which we have D rainy. We have rainy as the outlook, right? And what is the entropy for D rainy? It is 0.97 again. Okay, so now if we break it, so D rainy, if we break it, how many parts can we break it? Actually, although we had so let's break it on temperature first. Okay, and play tennis, let's say. So on temperature, what are the different classes what are the different values which we have? We had I think hot, mild and cool, right? So here you will see on rainy we do not have hot data, we have only mild. How many milds are present? 3 milds will be present and 2 cools are present. And here mild is yes, yes and no, and for cool we have yes and no. Okay, you can check it here. You can check it. See, for rainy, this is rainy, this is rainy, this is rainy. Okay, I'll change the color. So this is rainy, this is rainy, this is rainy, this is rainy, and this is rainy. Check out this. We have mild, we have cool, cool, we have mild, we have mild. So we do not have any hot data here, hot temperature in the rainy data, right? So we can discard it. We can discard the hot one. So we'll be just finding for 2 different data sets. So one is mild and another is cool. Okay, that is what we are doing it here. Fine. So now what you will be doing is, so what we'll be doing here is we'll simply find out the entropy for HD1. Let's say this is dataset 1 and this is dataset 2 on DR, right? Sorry, this is this is basically H on Y, this is D1. So this value will be D rainy, so D1 will have 0.91, so it will be 0.91, and H of Y on D2 it will be 1. Okay, and the information gain of D rainy on temperature, it will be 0.03. Okay, you can check it. Next, on humidity, I'll just write the information gains over here, you can do it. So D rain on humidity, if I divide the rainy data on humidity, I will get it as 0.03 again. Okay, and for temperature we have got it. Okay, and for windy, we'll be getting the value at 0.97. Okay, and so what is the highest value we are getting here? What is the highest information? 0.97 on windy. So here what we'll do is we'll build the tree from here on windy. Okay, maybe you are not seeing this, so I'll just show you the original one. So windy. Okay, I'll just draw this part. So the final one will be, so on the right hand side, so first we had outlook, right? So this is outlook. So we had three parts here. This is overcast, this is sunny, this is rainy. So here on rainy we had which data? 4, 5, 6, 10 and 14, out of which 3 were positive points, 2 were negative points. So we are confused what to predict, so we broke these on windy. Okay, we broke it on windy. Now windy has two parts, one is true, another is false. It is windy or not. And on this true we had how many data? 6 and 14. These are the data days. And for false we have 4, 5 and 10. If you are not seeing this, just listen to me. 4, 5 and 10 on false. Okay, these are the days on which we had windy as false. Okay, and now how many data points we had here? So 0 positive points and 2 negative points in true. Okay, and here we had 3 positive points and 0 negative points. So what we can conclude from this? We can conclude, when it is true, we can conclude that it is a no, we cannot play. But when it is false, we can say it is a yes. Okay, just focus on what I am saying. On the right hand side of the branch, we'll conclude that it is a yes. On the left hand side, when the wind is true, we'll conclude as no. Okay, so this is how you draw the entire decision tree, and finally it will look somewhat like this. Okay, now given any query, okay, any query, you can predict what the prediction will be, whether should I play tennis or not. You can right away get it. Okay, now here you can see, you can debate that we have not used temperature feature at all. Okay, you can say that, right? In this decision tree we have not used temperature. Yes, we have not used temperature because temperature feature is not that important when it comes to some conclusion or to some prediction. Okay, because the humidity, outlook and windy are enough to predict the class of the prediction variable. Okay, that is why we have not used temperature. Temperature is not useful at all here. Okay, or the other features are much more important than the temperature feature. That is why it is useless here. Okay, so in the next video I'll just show you some properties of the entropy, and there is a concept of Gini impurity which can be used as an alternative to entropy, and which is a much better approach. So I'll be explaining in the those concepts in the next videos. Okay, so see you in the next video. Thank you.